All right. Are we live? Should be live. Just gonna check that the audio is working. Hello, hello. Okay, good. Should be working. So I'll just do that. I'll do. Let me just check something. Yeah. Is the audio working? Yeah. How are we on that? Okay. Should be working now. Let me just turn the audio down on mine. Getting a bit of feedback. Just move that there. Just want to double check. Hello. Okay, good. Right, let's stop messing around and let's get on with it. So, today's stream about C++, we will be continuing where we left off with default initialization, i.e. assigning variables to a project, to an object. Now we left off at the different types of modernization, with these type of modernizations preferred, i.e. direct listing and direct list initialization using braces, and then value initialization also using braces. So let's continue from there. We'll just find where we are, and again I'm using learncpp.com. So we did that. This is where we got to. Okay, default initialization. When no initializer is provided, we call it a default initialization, which is this one here. They said they'll discuss later. Copy initialization, which is this one, an equal sign. This is typically the one you find in most languages like Java, JavaScript, Swift, where you want to assign something. Then we have direct initialization, which is different to that. Did I mess up slightly? Yes, I did. So I don't actually need that C, that equals there. So we can get rid of that. Okay. So let me just, no equals sign is required here. Okay. Default initialization, which is that one. As I start to get more accustomed to C, I will merge the two windows together eventually. but at the moment I like to have the code all in one window, and when I'm learning in the other. So what I mean by that is I will eventually be doing this. Although to be fair, I might just do that from now on, because it is a lot easier, and hopefully it will stop the ads. And I thought the text was going to be a lot shorter, a lot smaller. I can't seem to... Oh no, I can. Okay, cool. We will do it... Well, we're going to be reading that mostly. Okay, we'll make it a bit bigger. List initialization. Direct initialization. Direct list initialization, which is using the braces. Did I mess up again? No, I did. I didn't. Copy list. Okay. So it seems that in C++, when assigning or when creating initializers, you do not use equals. You use just the object, then the variable name, then the initializer, they use the brackets or braces, and you don't use an equals. You can use it, but as you can see here, it's very rarely used. List initialization disallows narrow conversions. One of the primary benefits of list conversions. This means that if you try to do a list initializer, a variable using a value that the variable cannot hold safely, the compiler is required to produce a diagnostic compilation error to notify you an example. So here we have an integer that can hold non-fractional values, initializing an int. Yes, because we're not using a double here, we are using an integer, meaning it has to be a full number. So here you would probably want to do double W1 and then 4.5, and that would compile. W2 would compile. Oh no, sorry, I'm wrong there. The compiles, but okay, no, I understand now. If you're using the direct list initialization, you are going to want to not use okay, list initialization, i.e. this, does not allow for narrowing conversions, i.e. if you put 4.5 here, and then based on what we learned last time, you would do standard character out D. I assume that would not run. So we'll run it in the terminal. Yes, okay. I understand now. Because, yes, no, I understand that. Because it does not allow for narrow conversion. Whereas using copy initialization, which is this one here, you can do that, and using direct initialization, but not direct list initialization, you can also do that. So 6.5 would work, but 4 wouldn't. So if we printed C instead of D, or ran C instead of D, we would then get 6. Okay, cool. And we're getting a percentage here. I wonder if that's because we're not running end line. I assume it is. And then even then, as we mentioned, if we are doing int and using a double, we may as well just do double. Save that, run that, and there you go, you get 6.5. But it is still possible to do an integer and have it there. Okay, so I will move that back to 6, get rid of this, and then just run it normally. Yeah, cool. Are we still, how's the sound looking? Yeah, the sound's still good. Okay. Don't want any feedback on my audio, if that's what it's called. Okay, now we can continue. So, what I think we should actually do is in our notes that we're making, in C++ basics, we will do direct list initialization does not allow for narrow conversions, aka writing or coding something like int, well, I'll use this example, int w1 4.5 will not compile. But int w2 but copy initialization and direct initialization will compile successfully. Will compile successfully, such as int w2 equals 4.5. This will compile and int w3 curly brackets 4.5 semicolon. This will compile. Okay. Save that. Yes, save that. And let's move on. Yes. And I'll just copy this. When should I initialize with 0 versus an empty brace? So we got the direct list initialization. I think also because eventually we'll get rid of this, it'll be useful to have in our notes. I think we'll put it there because I didn't actually add anything there. They are the following. Yeah, nice. Use direct initialization when you are actually using the initial value. When you using value initialization when the object. Okay. Initialize your variables. Initialize your variables upon creation. You may eventually find cases where you want to ignore this advice for specific reasons. Perform its critical section of the code that uses a lot of variables. And that's okay, as long as the choice is made deliberately. We'll explore in a later lesson. Initialize variables above. And again, I'll copy this. Yes, so if you are following along, I would recommend, whether you're on a Windows or whether you're on a Mac, to actually do this split window, because as you can see, the only ads I'm getting are on the actual other ads that are on the page, not going back and forth and back and forth. So that's nice. So that's just a minor point. Okay. Instantization. The term instantization is fancy and hard to pronounce. It's a fancy word that means a variable has been created, allocated, and initialized. An instantized object is sometimes called an instance. Most often this term is referred... Okay, we'll copy that because the actual definition is easy, but probably what makes it difficult is the actual pronouncing of it. So, initializing multiple variables. I think also what we'll do now is we'll get rid of these because we have covered initialization and the various forms, and we already have the notes here. I just want to... Actually, no. I was going to indent it a bit, but I like it the way it is. Initializing multiple variables. Yes, so we noted in the last episode, in the last lesson, that this is valid and this is valid, but also this is valid, but this is not valid. Yeah, and we noted that this is valid, but this is not valid. Yeah, cool. So I'll just get rid of that. But we do not initialize them, yes. You can initialize multiple variables defined on the same line. Yep. Copy initialization, direct list. Unfortunately, there is a common pitfall that occurs when programs okay. So if you are going to initialize, if you're going to initialize a variable and assign a value to it, you can do this, i.e. initializing a with b, a with 5, and you can do this, i.e. b is empty. But you cannot do, it seems, this. Oh, you can. But it seems, so what if I did a, comma, b equals 5. So it doesn't actually produce an error, but a is left uninitialized, and the compiler, well, we haven't actually run the compiler. So what if we actually ran the compiler, std out, and then we want a, and then we want, yeah, just that. Let's see if it runs. No, so you can see there, a just gets a random value of minus 90,488,744. Whereas if we did B and we ran, we get 5. Cool. So I'll get rid of that. So this doesn't work when running A. This works when running B because we've initialized it. But this will work. Yes. But as we mentioned before, this will not work. Yeah, cool. So then, if just to make sure, std cout a, and then save it. What's wrong here? What am I doing wrong here? Oh, there we go, because I've got 3 colons. There we go, that works now. So we should get 4, and we do. Nice. I just want to check, is that percentage because we're not doing, we're not ending the line? So yes, it is. Okay, so we don't need to worry about that. I thought it was maybe an issue with VSCode, but it's not. Okay, cool. Let's continue then. Unused initialized variable warnings. Modern compilers will typically generate warnings if the variable is not initialized, but not used, since this is ready desirable. And if treating warnings as errors is enabled, these warnings will be promoted. Okay, so if we initialize with the, that is the direct list initializer, right? Direct list initialization. Just trying to get the syntax in my head. So when compiling, so for example, if we did int x direct list of 5 and ran, we get nothing. But what about our debug console? But to run the debug console, we'd actually need to debug the file. Okay, so it doesn't actually I wonder if it's because I'll have to have a look at that later to see why that's not the case. Maybe it's a VS Code error, a VS Code difference. But essentially, because we haven't assigned it, that's why something like this wouldn't appear. I'll have a look at that off stream and see if I can find anything about that, whether that's a me error or whether I'm just not looking in the right place error, or what it is. Okay. And then obviously if we did std cout x and then we ran that, we would get 5. Maybe used attribute C++17. I'm thinking, what if it's because when we ran the debugger, I saw that we had stdgnu 14. I wonder if we changed our task JSON, and here we did whatever the most recent one was. So, what was it? Command Shift P. Then we did select configuration. Select configuration. Then we did JSON, was it? Yes, look. Yes, it might be. So, what if we changed this in our tasks here to std standard GNU compiler plus plus 20 C++ 23 GNU plus 23. Let's give that a go. Let's just see what happens. So I'm going to do it before std standard 26 C++, i.e. the for IntelliSense. And then what if we did this? So std equals GNU plus plus, and then I assume we would do 23 because it's the most recent one. 23, and we save that, and let's see if then when we, what did we do? We debugged the code. No, so it's still 14. And what if, did that actually change anything, or? Okay, so we've got that. Now we've got the standard GNU plus 23, so how do we get rid of 14? GCC GNU. Was it... so we did select configuration. Then JSON. I wonder if it is actually just the default VSCode that we have to deal with, because we know that now we have to, in every project, run this in VSCode, because the default will bring us down to C14, and then the default here I think was C17 initially, and then we knew that in the task file we had to do the std standard C++26, which is what gave us this within the arguments. But that is for IntelliSense, whereas this is whereas this is for, no, I can't do that. Whereas this is for the actual compiler and IntelliSense. But if that is for the compiler and IntelliSense, then then how is this running? I think it might be because of VSCode, to be honest. But I think we spent enough time on this. What might be useful is when we've actually learned all the code and all the syntax of C++, we might look for a different IDE. That might be what we have to do. It could be Xcode is possibly better. I'll have a look again off stream for that to see what's possible and what is better, and then I'll see what I need to do. Okay, because there must be a way to remove that. But anyway, let's move on. So there may be use attribute in C. In C++ 17, some cases, neither the above. So if you've got a undesigned an unassigned variable, what should happen is you get a error saying X is unused. So for example, so we know that that doesn't actually work. So if we do double pi, so it seems that may be used is essentially similar to like an optional. So I know the compiler doesn't, the VSCode doesn't work on this. So if we did a double pi and then braces for direct list initialization, 3.14, double of gravity of 9.8, and then a double of PHI, not pi as in 3.14, but 1.6. Come on. And then we did std character out, and then pi, and then create a new line, and then we did std cout, we'll do phi like in there, and then again we'll do a new line break here. So what we should see happen is we should see that when we debug the file, let's debug, yes, so we get pi and phi, but gravity is not actually being used. So in another, from what I'm reading here, in another IDE, we would get a warning error saying gravity is not being used. I think perhaps I might need to look into doing a new IDE and not doing VSCode, because it seems to have an issue somewhat here. But anyway, I will again, off stream, I will have a look at that. So To address this, C++17 uses maybe unused attribute, which allows us to tell the compiler it's okay that we're not using, that a variable is being unused. The compiler will not generate unused variable warnings for such variables. So, essentially, maybe used, it seems that maybe unused is similar to an optional. For example, in Swift, you would do var name, and then if you wanted an integer, you would do a question mark. It's something similar to that, I would assume. They don't say it here, but from my experience, that's what I would potentially think. I do not complain if certain variable, such as gravity, is not used. Okay, that makes sense. So we'll keep that actually. So again, practice is always good. So what we'll do is we will do, so it's bracket, maybe unused, bracket, maybe unused, and then again maybe unused. So i.e. Do not complain. I wonder if the IntelliSense is not appearing because we are still on C++ 14 for the GNU, which makes me think that perhaps I should switch an ID. But again, enough about that. I will look at that off stream. That's not important for now. Okay. Additionally, the compiler will likely optimize these variables so you have no performance impact. The maybe unused attribute should be applied selectively so that variables that have specific and legitimate reasons for being unused, because you need a name of values. But which specific values may vary. Otherwise, unused variables should be removed from the program. True. But just because they're unused doesn't mean you're not going to use them in the future. In future lessons, we will often define variables we don't use in order to demonstrate this syntax for certain concepts, making use of maybe unused, allows us to do so without compilation error warnings. Would help if I spelled it correctly. Maybe unused. Maybe unused. Let's see if that then compiles. So it does recognize it, but the IntelliSense doesn't. Okay, I guess that doesn't really matter as long as it's working. So now what we'll do is, what is the difference between initialization and assignment? Initialization gives a variable an initial value at the point where it is created. Assignment gives a variable at a value at the same point the value is created. At some point. So initialization is when you first create the variable, then the assignment is when you assign it later. Okay, we'll add that to our notes. So we'll just close the debugger, and then the difference. So the difference between initialization and assignment is initialization gives a variable gives a value. Are we okay on the stream? I just got an error. Is my Wi-Fi all good? Yeah, it seems to be. Stream is still running. Is this website still loading? Maybe I need to plug in my laptop, potentially, because the stream health says it's poor. So we'll just refresh this. No, the internet is still up. Okay, I wonder why that is the case. Okay, there we go. It was just dodgy part of the stream, maybe, something like that. Okay, so anyway, back to it. Initialization is when we assign the value at the initial point, is when we give a variable a value at the initial value stage, i.e. if we did here pi 3.14, and then assignment gives the variable a value at some point later, i.e. if we did pi of empty and then later we set pi to 3.14. What form of initialization should we use? Direct is always probably the best for this. What are default initialization and value initialization? Default is no initializer, as you can see here, and our value initialization is empty braces. So they're both the same, i.e. they both don't have an initial value, i.e. no initial value. Default is when a variable has no initializer in most cases. Value initialization is when it has an empty brace, yes. In most cases this will perform zero initialization. You should prefer value initialization, yeah, i.e. the modern, more accepted techniques. Okay, nice. So now we'll go on to the next lesson. Introduction to I/O stream, i.e. like we learnt last time, I/O is input and O is output, and then stream is a stream of data. C out, character out, I assume, character in, and end L. I'm just going to have a quick break, so I'll be right back in a minute. Let's see, is it possible to... Yeah, alright, I'll be back in a minute. Okay, and we're back. Alright. Alright. Let me just check something. Everyone good on that? Okay, cool. Right, let's continue. Okay. Yes, so we learned in the last lesson that the main, to allow for input, i.e. the user to enter something, we need to include the library of IOStream. IOStream is the input, I in IOStream is the input, O is the output, i.e. character out, and then the stream is the stream of data. Character output. So, did we make a note of that last time? Yes, we did. And we need the operator of the open crocodile brackets. insertion operators. That's what they're called. These are called insertion operators. And as you can see here, the insertion operators allow us to produce or print pi and bhi. Yeah. It might be helpful to imagine the insertion operator and this operator as a conveyor belt. So a new line. Okay. So instead of using the /n, we can use std standard end line. So let's give that a go. Std end line, and then we save, and then we run, and again we still get the 3.14 and 1.16 on different lines, and we won't bother doing that. Separate out the statements, so the result was like this. Yes, so if we didn't have the std end line and we didn't have the /n and we ran the code, we would get that, which is not what we want. So we'll do at the moment I personally prefer the n because it's a lot simpler to type out. Save, run, and there we go, we get 3.14 on both lines. std cout is buffered. Consider a roller coaster ride at your favorite museum park. Passengers show up and get in line. Periodically a train arrives and boards passengers with a max. When the train is full, or when enough time has passed, the train departs with a batch of passengers, and the ride commences and passengers are. Instead of requested output, get in line, and so on. Does that mean it's not as useful? Okay, yeah. Yeah, it seems like it is. Okay, yeah. Using std nline, so we can use std nline to break and create a new line, but std nline is buffered meaning that all the data with std end line essentially is gathered up and then outputted, i.e. the disgusting toilet analogy. So this means that if the debug does not work, we will, or the debug, that if the code crashes, we will not get the outputs that happened before the crash occurred. Okay. Yeah, so we get multiple flushes, which is slow and unnecessary. So when outputting text, we typically don't. To output a new line without flushing, so we can instead use n, which does not flush and is therefore not buffered. It's simply buffered. It simply moves the cursor to the next line. So I think potentially then that means if we're not buffering and we can continue, then, or we want to continue as fast as possible, we will be using n going forward. So again, there's always conventional and not okay. So if you are author's note, best practice is to use n over std. So again, we'll just copy that and we will say the best practice therefore is to use \n, and it needs to be a backslash, not a forward slash. Yes. Okay, so std cin. So character in is std cin is character in and allows for the user to produce an input. So in character out, we use the insertion operator. We use the extraction operator. So again, the best way to do it is to practice. So we'll get rid of these. Oh, actually what we'll do now is we'll put these to comments. If we do not use a variable, we can use maybe unused to essentially create something like a optional. And then that, okay, cool. Now we'll move on to character in. So we have std character out, insertion operators, that's what they call, right? Insertion operators, yeah. Insertion operators, enter a number, and then we have an integer of x with a display list, direct list initialization, direct list initialization, and then we have std character in with the exertion, and then we want x. Then we produce std character out with the insertion, you entered, and then still, because we're using character out, we want to be using the insertion operators, even though we're using what the user put in the character input. So we did x and then a new line because we don't want it to buffer. So yeah, we'll return, we'll save, and we will run, and we'll see what happens. So enter a number 5. You entered 5. Nice. So that works. I don't think we need to spend any more time on that. Okay, and we can enter multiple. Things. I don't. Let's just practice, just for sake. Std cout, because I want to get as good as possible. Insertion operators. Enter 2 numbers separated by a space, and then we'll do that. We'll then close it. We'll do int x, and then semicolon. We'll do int y, and then semicolon, and then we'll do standard std character in, and we'll do exertion, and we will do x, and we will do y, allowing the user to enter what they want, what the 2 numbers they want. Then we need to do std character out, insertion operators, and then you entered space x, y, he uses x and y, so we use x, and y, and then we will create a new line. So we run that, all semicolons, nice. So we'll do enter a number followed by a space. So we'll do 5, 6, 7, and then we'll do 1, 2, 3. You entered 5, 6, 7, and 1, 2, 3. Nice. stdcn is buffered. Okay. In the price section, we noted similarly inputting data. So is there a better way to do that? Okay, the extraction operator removes the characters from the front from the initial. Okay, so std character in is buffered, but through the use of \n, we are able to terminate the buffer. Okay. Which is why we then use \n. Okay, that makes sense. So just to make sure, stdcout uses the extraction operator and stdcin uses the insertion because we're inserting or getting the user to insert a value operator. Okay. Okay, let's try the quiz. Consider the following program we've used in above. Include iOS stream for stdcout. Yep. stdcout, enter a number. Ask the user for a number. Int x. Let me just check something. Okay, all good. Yes, so std character standard character out, enter a number, ask for a number, integer x, define the variable we want, character input with the insertion operator x, get a number from the keyboard, std you entered x n, and again n stops the buffer. The program, run the program multiple times and describe results from the output, from the input. So if we did a letter H, I assume it wouldn't work because that is a character and we're asking for an integer. A number, a fractional number. Well, we know previously that the direct list doesn't narrow. So I assume that would either narrow it or i.e. to 3, or it wouldn't run at all. And then a negative integer I think would be fine. A hello world such as hello, that wouldn't work because it's a string. A really big number I assume would be fine. A small number followed by letters, I'm not sure about. A letter followed by small numbers, I don't think that would work. A +5 I assume will be fine. And then 5b6. So instead of looking through the answers, let's see if I was right on any of them. So we will get rid of this. We will run std character out in insertion operators. Extraction operators. Character out. You entered X. And then we obviously need the return 0. So if we save that, something wrong? No, okay, it's not. So you entered, so what we'll do now is we will wait for the code to run, enter a number, we'll enter a H, so what we'll do is H, and we got a 0. 0 is always printed. What's happening? An integer cannot hold a letter. So extraction completely fails of X. Yes. So now if we run the code again and we do 3.2, it will either narrow it or won't run. It narrows it. Okay. Result, the fraction is dropped, not rounded, giving the number if you're wondering why it isn't disallowed narrow conversion only allows during list. Okay, so if we did 3.2 here, then it would drop, but because we're assigning it later, it doesn't drop. Okay, a negative number such as 3, I assume would just run 3. Yeah, no, -3, so that's fine. Such as -3, show solution. And then we'll do hello. You entered 0, again, similar to our H, because it's a character or a string of characters. Yeah, a really big number, such as 3 billion, which is 9 zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3. Enter. Oh, we don't get 3 billion. We did get whatever that is. X cannot hold numbers up to a certain size. Okay. If a value larger than X, we'll discuss this in signed integers later, in a later episode. Now we'll do 1, 2, 3, ABC. Nope, not in there, in the terminal. 1, 2, 3, ABC. You entered 1, 2, 3. And then the ABC is put out of the extraction. ABC 1, 2, 3. I assume, would that just create 1, 2, 3 again? Possibly. Let's have a look. ABC 1, 2, 3. You entered 0. That's because the first character is probably the first character is a character, not an integer, maybe. Yeah, an integer can't hold a letter. Okay. So it's 0 plus 5. What happens? We'll run plus 5. We get 5. And then I assume this, let's have a look. I assume this will be 56. Or it will be 5 because it can't hold a letter. 5. Okay. Yeah, so it treats the B as invalid, so the extraction stops there. Okay, that makes sense. Question 2: a programmer, the user enters 3 values. Okay, I think that's possible. I should be able to do that. So we will, first of all, we'll create an integer of A. We'll create an integer of B. We'll then create an integer of C. And then we'll do an std character out, and we will ask the user to enter 3, we'll do capitals on it, 3 numbers with spaces in between. Then we want to do std character in, and we want extraction operators. So we'll do A, we'll extract B, we'll extract C, and then we'll close off a semicolon. We need to close off a semicolon here. And then we will do std character out, insertion operators, and then we will do you have entered, and then a space, you have entered A, you have entered, okay, so he wants a he wants a comma after each one. So we'll do that, we'll do a space, we'll do, no, we won't do that, we'll do B, we'll do that, and then we'll do and then we'll do C, and then we'll finish it off with a nice line break, and then we will return 0, and then obviously we need semicolon as always in C++. So let's give that a go. First of all, let's clear our terminal. Let's ask the user to enter 3 numbers with spaces in between. So you got 5, we'll do actually 4, 5, 6. You entered 4, 5, and 6. So why? Okay, because we're doing a space here. So what I'll do is I'll get rid of that space there, and then hopefully that should then improve it. So let's enter 4, 5, 6. You have entered 4, 5, and 6. Nice. Is there anything we missed? Well, he used X, Y, and Z, but that's okay. I'm fine with that. Okay. Uninitialized values and undefined behavior. Let's move on to the next one. Initialize, the object is given a known value at point of definition. Assignment, it is given at a point beyond the definition. Uninitialized, okay, that makes sense from what we've learnt earlier. What I'll do is here, I'll do, I'll just copy and paste it, to be honest. Okay. So yes, so initialization is at the very start. So if we did a being equal to 1, that would be initialization. Whereas if we didn't define C or didn't ask for C, that would be uninitialized. And then assignment is when we have something like B, and if we only asked for B, that would be assignment later. No. Is that right? Yeah, because I assume it would be because we're assigning it late. We're assigning it later. Okay. Using values of initialized values can lead to unexpected results. This variable is uninitialized because we haven't given it a value. Okay, so what we need to do then in that case let's have a look at that then. Let's have a look at int x and then std character out x. And let's see what we produce. Okay, so something massively different entirely because the computer just assigns a random one. Interesting. So if we have a uninitialized so if we have an uninitialized uninitialized variable, we can use the do nothing and the compiler will think we are assigning a value to this variable. Okay. Implementation of defined behavior and unspecified. A specific compiler and the associated. Okay, so let's try that then. And we'll discuss this later. Okay, let's move on to the next one. Keywords. Keywords, 92 keywords. These keywords are also. Okay, just for sake of coming back to in the future, let's do chapter 5, and let's do C++ keywords. And we'll go down here and we'll do chapter 5 C++ keywords. We'll then close off chapter 4, and then in the future we'll just close off for chapter 5. Okay, so it doesn't seem he's actually going over the keywords. So what I'll do is I'll just copy and paste all of these so that we have them in the future. Feel free to do that as well if you're following along. So now it seems we're getting into syntax with this, identifying naming rules. So I am fairly comfortable with syntax in terms of naming rules. I've used snake case, camel case. I've forgotten the one where it's all capitals. I assume it's just uppercase maybe. But for example, in Swift or in JavaScript, you would use camel case, which is where your font is like this. Camel case, and then we have snake snake case like that. Yes, that's conventional, unconventional, unconventional, unconventional. Yes, there we go, snake case. I think we can move on to the next lesson, personally. I'll move on to the next lesson then. If you do, or if you're unfamiliar or uncomfortable with the syntax, i.e. the naming of certain things, then feel free to go back to lesson 1.7. But I am personally going to move on. White spacing and formatting. Okay. White space is a term. Separating languages. Yes, because in code, for example in HTML, you could have a million lines, but the HTML will only treat it as one line, one space, not one line. In HTML, if you wanted a line break, you would use BR like this. But we're not doing HTML, so we can forget about that for now. Okay. Yes, so if you did int x is fine, but if you did int x, that wouldn't be fine, because there's nothing to assign it to. It doesn't read it as integer and unassigned x, whereas that does. Int main. Yeah, you see, this is correct code, but it's very difficult to read. You're like int main std cout hello world return 0. I mean, you could write it like this. Sometimes in languages like Swift or JavaScript, if you have something on one, usually if you're only doing one thing in a function, you can write it on one line. That's a little better. And the following is even better. Okay, so instead of doing the braces on the same line, you could do that. Okay. I have always personally used the braces on the first line that I create my function with the initializer. So maybe going forward, I might. So if going forward you see this, it's the same as this. I'll have a play around with that to see how I feel about that. 4 spaces, yes. So here, for example, you have 4 spaces. Some do 3, some do 2. You can adjust it here by going to changing views, and if you press tab on your keyboard, it will jump 4 spaces rather than 8. For example, if you did 2, you would do this, and then it would only jump 2. Whereas if you did spaces are 8, you would do here, and then it would jump 8 spaces. I'll leave it back to 4 for now, as recommended. 4. So then you go here, and you see it only jumps 4. Okay, nice. Okay. So why not? Let's we are following along the tutorial. So let's start putting our braces here in C++ going forward. Whether I remember that is another thing. Yeah, I'm familiar with all that. That would make it easier. Harder to read, easier to read, harder to read. Yeah, I do sometimes find that I write my comments like this, whereas perhaps I should write my comments more like that. Going forward. Easy to read. Yeah, some more spaces. And as we discussed earlier in our last episode, last stream, we use comments as a way to remind us as to what a certain thing does. I.e., if we're doing something difficult, like a difficult function or difficult calculations or whatever, we can come back to it and see in plain English what it's actually doing. And as you can see here, the best practice is to always be consistent. Okay, nice. Let's move on to the next episode. Next lesson. Introduction to literals and operators. Okay, I'm just going to take a quick break and I'll be back in a second. Okay, how are we doing? Is my just want to check that I'm still live. Hello. Yeah, okay, good. We're still up and running. Cool. Let's continue. Literals. We got a character output of hello world, and we got a integer of 5. A direct list integer. Correct? Direct list initialization. Okay, so a literal or a literal constant is a fixed value that has been inserted directly into the source code, whereas a variable is something that is defined. So let's just copy that. On line 5, on line 5, we are printing the value to the console. When the compiler compiles this, it will generate the standard character output to print 5. This 5 is compiled to. Okay, understood. Operators. Yeah, BODMAS or PEDMAS, I think, as the Americans say. But us English, us Limeys calls it us Limeys call it BODMAS, i.e. BODMAS like that. Brackets, order, bod divide, multiply, add, subtract, like that. There we got the insertion, which is for character input, and exertion, which is character output. Extraction, sorry, not exertion. Ternary operators. Ternary operators, like for example in Swift or JavaScript, would be a useful acronym is WTF, which is what we're looking for, what condition, condition, what happens if it's true, 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 and then what happens if it's false. But we'll cover those later. So this should produce 3 plus 4, 7. Nice. I won't bother doing coding out these because it's basic maths, and I'm not here to do basic maths, I'm here to learn C++. So 3 plus 4 is 7 minus 5, so that should produce 2. Wow, 2. 2, there you go. 2 plus 3 times 4, so going back to BODMAS, we do multiplication first, so 3 times 4 is 12, plus 2, so that should be 14, he says. Yeah. Extra credit, so we got 2, so that std out, so that would just produce 2 equals 5? Oh no, x equals 5. Okay. Because it's not fixed. Okay, no, that makes sense. That does make sense. Expressions. Okay. So now we got another method or function that does that's not actually a main. Bit more interesting now. So what we'll do is we'll create a function. Return 5. Cool. And then we'll do int a to int b and then int e. And then in e we will return 5. Semicolons for all of them. And then we'll just copy what we have here. 2 plus 3. 2 times 3. Just to make it easier to read. Plus 4, and then D will be B. Okay, cool. Get rid of that. And then, for example, if we said we wanted to see the character output of A, and then we also wanted E. So what that should do is that should produce 2 and 5, or 25, because we haven't actually put spaces anywhere. Nice, 25, even though it's 2 and 5. But we're aware of why it's 2 and 5. 25. That's a literal, yeah, like we covered in the last lesson. Yes. That is a statement. Yes. That is a statement that contains an expression. That is just an expression without a statement. An expression statement. An expression. Determine what values the program. Okay, so instead of actually writing it, let's try and use our brain. So determine what value the following program outputs. Do not compile the program, just work on it line by line in your head. So we have a standard output of 2 plus 3, which will just be 2 plus 3. We'll have an integer of 6 with a direct list initialization of 6. We'll have an integer of y of 6 minus 2. We'll then have a character output of 6 minus 2, which will be 4. Then we have an uninitialized, or a direct list initialization of nil, and then you've which is unassigned, and you've then assigned z to x. So z becomes 6, and then you do 6 times 6, so 36. So I assume the only one I'm a bit cautious of is the 2 plus 3, whether that produces 5 or whether that produces the literal string of 2 plus 3. So we will either get 2 plus 3, we should then get 4, and we should get 36. I won't compile it, I just want to see if I'm right, like he says. Let's have a look. 5, okay, so it does, and 4 and 36 were correct. So they're not treated like in other languages as a string, it's literally just 2 plus 3. Nice. Okay, cool. Now we can move on to the next lesson and develop our first program. The preceding lessons. Now let's actually get into the good and interesting stuff. Because you can learn as much theory as possible. It's only when you actually get into the practice that you actually learn. We'll create a simple program. First, let's create a program that asks the user to enter an integer, waits for the integer input, then tells them 2 times what the number is. The program should do the following. Assume I entered 4 as the input. So, should we give it a go ourselves, just to see if we actually know what to do? So I'll get rid of this. We will then have an integer of, let's call it x. We will then have a std character out of enter a number you wish to double. Or let's do times by 2 because double is obviously a float number. Times by multiply. To multiply by 2. And then, that's why it's the error. And then we will have Why is it? Okay, because I haven't done a semicolon there. Then we will have an std character in with insertion operators, and then you will enter x, and then we will have an std character output with insertion operators, and then double that integer is, and then I assume we just need to do this x times 2, and then we do let's just do a new line. Is that all good? No, we're getting a complaint. Expected an expression. So what if we got rid of that? And then would that run correctly or not? So let's just give it a go. Enter a number, we'll do 4. 4 multiplied by 2 is 8. Cool. Okay. New programmers often try. Yeah, return 0. We know we're going to get the output in the console. Enter an integer, enter the number you wish to multiply. Yeah. And we're using the, in cin, remember it's insertion, and character out is x extraction. We got int num. Again, that could go here or that could go under cout. I've put it here, but he's put it there, so that's fine. It's producing that error because this is the exertion. This is the exertion operator, but he is doing, and we are doing character in. Therefore, we need the insertion. So this needs to be flipped. There we go. Double the number is. Okay, so at least I didn't do the not good solution. And did I do the good solution? Okay. Yeah, I suppose that's probably better. The preferred solution. Oh, there you go. I did the preferred solution. Mostly good. Okay. Well, at least I know I'm somewhat preferred. Okay. Use an expression to multiply the number by 2 at the point we're going to print it. Yes, because otherwise you're just wasting code here. Cool, nice. Modify this for the best solution. Okay, let's give that a go. Let's start again. We'll do int x. We'll do std character out, and integer, and then we'll get the user to enter the integer. We will then set the integer to be, what did we just do? We'll do a character input with the insertion operators. Just trying to get used to it. Where we do X, and then we will have a character output of, first of all, we will have a character output of double, and then what we'll do is we want another insertion operator, and then we'll do X. And then we'll do space after the X is, and then we'll do that, and then we'll do X times 2, and then we'll end the line there because we want to do triple then eventually. So we'll do a new line, we'll then do std character out, and essentially we'll do the same, but we'll do triple. Okay, triple X is X times 3. And then we'll do that. And then obviously the one thing we're forgetting is we need to return 0 because it's an integer function. Nice. So let's give that a go. First of all, we'll just clear the console. And then we will run. Enter an integer. Let's do 10. So we should produce 20 and 30. I know he's doing an example of 4, which will give you 8 and 12, but why not be different? Okay, so I've done something wrong there, and that's what I've done wrong. I've done a / instead of a \. Let's clear our terminal again. Let's run it, and let's do 10, and we should get 20 and 30. Cool. Nice. Chapter 1 summary and quiz. So statement is a type of instruction. Statements are terminated by a semicolon. I think it's just best to copy this rather than just type it all out. You can use comments, yeah, data types, direct initialization we've already covered here with the more modern techniques. So a little operator is something that the user has typed in, or something that we as the coder have used and is directly within the code. How are we looking? Okay, we still good. What's the time? 12:30. We'll probably go until 2 o'clock, I would say. We're making good progress. We'll take a break briefly, sometime soon. So let's continue. Keywords, we've got them here when we come back to it. what is the difference between initialization and assignment? Okay, now we get to see if what I've been doing I've actually learnt. So initialization is when we first define the variable, we set a value to it, whereas assignment is when the initializer does not have an assignment, and we assign it at a later point in the code. How many times can a variable be? It can be initialized once and assigned many times. There you go, nice. So I am learning something, hopefully. When does undefined behavior occur? When we don't define the variable. And what are the consequences? The consequences is that it won't run anywhere. And don't we use maybe unused? The impacts of undefined. Okay. There we go, nice. A real programming question. Write a programming that allows the entity to use a second number. Okay. Molto interessante. So we want to enter an integer, which could be anything. Then we want to integer another one. And then the program should match. So we'll do 6. Okay, so we want to do plus and minus, so it could be anything. So let's get rid of this. We'll do integer a, and make it unassigned. We'll do integer b, and we will make that also unassigned. We will then say std cout, enter an integer, integer. The user will then enter the integer, and then we will have another character output of exertion. Still trying to get used to it. Extraction. No, it's not exertion, it's extraction. Yeah. Extraction operator. Enter another integer. Then we need to do I just realized we need to do a character input here. So std character input with insertion, and then we need to do a. Then what we also need to do is we'll need to do that. No, we don't, because it will do it itself, won't it, surely? Let's have a look. Enter another integer, std cin, and then it'll be b, and then we will need to do a character output of a, plus b is a plus b. And then we will do that. And then std will do the same thing. C out a, but this time it's minus b is a minus b. And then return an integer of 0. My code is giving me an error. Why is that? Because I haven't done a semicolon on 0. That would be why. Cool. So we enter an integer, he enters one, we create a new line, we enter another integer of b, we then assign them through here, and then a plus b is a plus b. Yes. Then we have a minus b is a minus b. Let's have a look. Enter an integer. Let's just copy the comment, the example. 6, enter another integer. 4, 6 plus 4 is 10. 6 minus 4 is 2. Nice. And with that, we have done the first chapter, which is, the first chapter was basic C++, I think it was. Introduction, getting started. Okay, so now, oh no, it was C++ basics because we did this in the first episode, in the first stream, and we ended here in the second stream. Well, we ended here in the first stream as well. Okay, nice. Now we can get on to the real things, functions. All right, I'll be back in a second. I'm just going to take a little break. Be right back. check if everything's all right. Okay, we're all good here. Okay, let's continue. All right, functions. What we'll actually do first is, before we get onto functions, we will save in our Git repository on our local device. We'll see how much into functions we get before we'll end the stream. So, we didn't really add much, so followed along the Learn CPP lessons and completed the C++ Basics lesson 1. Yeah, I think that's it. That's good for that. Tutto bene, and then today's date is what? The 30th. 30th of July 2026. Cool. And day 2, lesson 1 we'll do. Day 2, save 1. Because once we've done some things on functions, we'll obviously save there. So commit. Nice. So that's all good. And let's move on to, let's close that. It's clear. We'll get rid of, we'll get rid of that for now. And we'll just practice a standard cout hello world. And then we should print hello world. Hello world. Cool. And then I just want to get rid of that. Yeah, cool. Oh. So, functions. A collection of statements that execute sequentially, so from top to bottom. Designed to do a certain job. We've covered main. Yes, we've covered main here. Split them into smaller chunks. Yeah, because imagine writing so many functions within main, or so many statements or whatever in main. Function calls, which is what we did with that when we did the int 5 and then we return 5. Return. Yeah, so that's what we do. And then you would set int a being 5. So there you are calling, the function call is here. Okay. So, now let's do. So it looks like we're using for function names camel case. Yeah, so previously we've dealt with, no, I don't want to save the website, I want to save this. So previously we have used integer, but we can also use, it seems, void. Let's do this. So void print, and then we'll produce the character output, produce an output of then we will do we'll get rid of that std, character output, we'll do character output of main, and then we'll call the function do print, but we must use parentheses to actually call it. which will then, so we're starting the main, then we start or call the print, which should then produce indoPrint, and then we will then do std character out ending main. So that should produce starting in main. Then we will do run doPrint, which will run indoPrint. Then once we have that, we will do ending main. So let's have a look. Let's clear the terminal. Let's run this. There we go. Nice. Starting main. We're currently indoPrint, ending main. I am fairly used to or fairly comfortable with my calling of functions. So therefore I am not personally going to make a a note of this. But if you are uncomfortable or unfamiliar with functions and you don't know that you need parameters to, brackets, not parentheses, brackets to call it, then I would suggest making a note of this. Yes, so if we call doPrint again, like it says there, we should get indoPrint twice. Yeah, we'll just clear that just to make it obvious. There, nice. Functions can call functions that can call other functions. Yes, so you've already seen that in the main we can call doPrint, and then doPrint can also be called in other things. So let's, again, the best way to practice, or the best way to get better, is to simply practice. So let's get rid of this. We will get rid of this, we'll do void. So we use void instead of integer if we don't want an integer to be returned. We have, at the moment, the only return types we've dealt with are void and integer. So do b. No, you don't want that, you want that. And then we want an std character out. We are currently in B. Then we want another function, again void, do A, and then we want std cout, character out, and then we are starting do A with a line break, and I'm going to add a line break here as well. And then we are going to call do B, again with the brackets to make sure it's called correctly, and then we're going to end ending do A. Cool, nice. And then a line break, and then in our main we will do a character output of starting main, lowercase, and then we will line break, and then we will run, instead of running do B, because we don't want to, if we ran do B, it would just run this code, whereas if we ran do A, it will do starting in main, starting in do A, then stops do A, goes into do B, and then we go into do A again. So we don't need to do std because we've already done it here. So then we would call do A and there. Then we are ending main, and I just want to add some space just to make it more clearer. Ending main and a new line. So that should print starting in main. We are then starting A, we are then calling do B, we are then ending do A because do B has already been called, and then we are ending main. So that should run like that. Let's have a look if that is correct. Starting main, starting do A, we are in do B, we are ending do A, we are ending main. Nice. So nested functions are not supported. Okay. So if you're unfamiliar with nesting, nesting is basically where you put something that is similar to that one thing and you are then putting it in, you're doing another thing in that said thing. For example, if you were doing a for loop in Python, for example, you could do a for loop within a for loop. That is an example of a nested for loop. As you can see here, unlike other programming languages, functions cannot be nested. The following program is not legal, which is why we have to create the function outside in the first place, and then call the function in main. So for example, if we did void b and we moved void b into the main, that would not be possible. So we need to move it, foo in this case, we need to move foo outside. Yes, that makes sense. Okay, quiz time. The body. So, again, like they said, let's not okay, good, because for a second I thought that was the exact same as this one. So we have do B, so do B will print in do B with a new line. We have do A, which will print in do A, and do A calls do B. So do A function will run this in do A, then straight after that it will run do B. So in do A will run, then in do B will run, then our main function where everything will occur So this is what should occur as far as I'm aware. So we're starting in the main. We're then calling do A, which means we are going to print in do A, but because do B is in do A, I know it's confusing, but maybe if I get rid of do, because B is in A, we will be running in A and in B. But then after that, we will be calling B again. So we'll get 2 B's, and then we're ending in main. So the print should be, I'll do it in notes so I don't get any errors. The print should be something like this. Starting main, and then we have a line break. Then we are in do A, and then because in A we are calling B, so we need to do in do B, and then because after do A has finished running, we will then be calling B, so in do B again, and then we are ending with, so that's what should appear. Let's see if that's correct. There we go, nice. We got 2 B's, we got 2 B's and 1 A, and then starting and ending main. Nice. So what's the time? 1 o'clock. Function return values. How many lessons are in functions? Is it quite a lot? I assume it would be. Okay, quite a lot. Or maybe do 1 or 2. How about we go until, let's say, around 1:30. So another half an hour. So I will be back in a minute. Okay, back. Let's continue with functions. Okay, nice. Right, let's continue then. Function return values. Value returning functions. How are we on our stream? We still good? We still up? Yes, we are. Nice. Excuse me. So consider the following program. You got an integer main, you got a return type of integer, you have a main function, you get the value of the integer, you then have a number, the user then inputs a number, the print is doubled. It's a fairly simple one. The program is composed of two conceptual parts. First, the value from the user, then double the value. Although this problem is trivial enough that we don't need to break it into model functions, what if we wanted to? I.e., what if this just keeps getting bigger and bigger and we want to double it, triple it, quadruple it, or we want to divide it by 2, divide it by 3, divide it by 4. We would need to put it in another function. So, yeah, that would be, because we would put void, that makes sense, because we would put void because we don't actually want to return a number or anything. We would enter an integer, we would get an input, and we would then get the input. So we ask the value, yeah, and then we convert the number that is true. While the program is a good attempt, it doesn't work, yeah, because in our get the value from user, then this, we set it as input, but in here we're getting a number. So do we use a method, like a method? Because in some languages you can do, for example, if do a was asking, you can do a, and then you would call the input, and then you could perhaps set the input to equal to number, perhaps. Sorry, there's a fly in my room. It's so hot today. I have to leave the windows open. Hopefully it's not picked up, but if it is, what are you going to do? Okay. It looks like he wants to go out the door. So let me just. Well as C++, we also get flies coming in here, so that's always nice. Okay, back to the functions. Yeah. When function getUserFromValues is called, the user is asked for an integer as expected, but when they enter, it gets lost. The variable num gets initialized but is never entered, so the program always prints the answer 0. What we are missing from is the return type at the moment is void, like that. So when you write a user-defined function, you get to determine whether the function will return a value back to the caller or not. To return a value back to the caller, 2 things are needed. So when writing a user-defined function, we must determine whether or not the said function will return a value. This involves two steps, two things. First, to make it stand out, first we will okay, sorry, I was just checking something. First, your function has to indicate the return type. Note that this doesn't determine what specific value is returned, it only returns the type that will be returned. So first we must indicate the return type that the return type of the value that will be returned, e.g. an integer, rather than a void. And then I'll just copy and paste that. Second, inside the function that will return a value, i.e. get the value from user. No. We use a return statement. Is that what I'm talking about? Inside the function that will return the value. Yes. We need to use a return statement to indicate the specific value to be returned. If I can actually spell returned correctly. To be returned. To the caller. The return statement consists of return. Yeah, so I assume here you would do something like return input. I'd assume that's what you'd do. And always end with a semicolon. Always, always, always. The return expression. Yes, so in that example, when we did in a previous lesson, but this stream I think it was, we did int 5, and then we returned 5, and then we called it. So should we I haven't actually I haven't actually done the code. So what we'll then do is we'll actually, first of all, let's create the code, and then let's put our idea before the teacher tells us. So first of all, we'll do the standard one: void get value from user, and then we will have a character output of enter an integer, and then we'll have an int of input with an unassigned value, and then we will do a std character input input. Then in our main we will call get value from user, and then we'll set the integer to number, and then we'll produce the std cout num doubled is num times 2, and then we'll end it with a full stop and a line break. So what I assume, we need a semicolon there and a semicolon there. So what I assume we need to do is we need to do int, and then we return input. That would be my personal guess as to what we need to do next. So before we do that, let's see if I was right. Nice, I was. Oh, okay. So we need to initialize so the number will, okay. So then we need to initialize a number with the return input. That does make sense, yes. Because we need to get, somehow we need to get the input. We need to get the input from that function, the get value function, and then we need to put it in our main, and somehow we need to assign the number, or we need to initialize the number, because we're not assigning it, we're initializing it, because we're creating a number, we're creating the value at the very point. So get rid of this, we do get value from user, and then obviously we need brackets to call it. So that should work. Give me an integer, 5. 5 doubled is 10, and we'll just do a space there for future. Okay, that does make sense. I just missed out the initializer point. So we'll save it, we'll run it, and then we'll do 10. 10 doubled is 20. Okay, nice. When the program executes, the first statement of main will create an integer. Yep. And because our value is an integer, our get value from user is an integer, we can then pass it in the integer of num, i.e. this is an integer, So that allows us to pass in an integer here. How much? And that's quite a lot. Revisiting main. Yeah, okay. I think we will leave it here today at revisiting main. I'll just leave a comment here. Left off at in lesson 2.2. Okay, cool. So in today's lesson, we finish the C++ basics. We then now are moving on to functions. And now what we want to do is we will just do what we did. We'll do day 2, save 2, and then we'll just do beginning learning about functions and the various return types and how to use the return types. Ok, tutto bene, and it is the 30th, right? 30th of July. And we'll commit that. And so the next stream, i.e. hopefully tomorrow, we will be leaving, or we will be continuing off of the revisiting the main. Yeah, we'll just clear the function. We'll clear the terminal, sorry. We'll get rid of the right sidebar. We'll save just to make sure. Just double make sure. And yeah, I think that's it. If you followed along, hopefully you enjoyed the video. If you did enjoy the stream, comment what you enjoyed. If you are following along, say what you followed along with. Hopefully the extraction and insertion operators for character in and character output, with character output being exertion and character input being insertion because you're inserting. Hopefully that wasn't too confusing, and hopefully the functions are beginning to make sense. If they're not, just feel free to play around with it, because practicing is the only way you can possibly get better. And please comment what you enjoyed, what you think I should cover, and please subscribe, like, comment, subscribe, all that good stuff. And I will see you in the next stream. I'll see you hopefully in the next one. Right. I'll see you later. Bye.